Hello, my name is Jonathan Doolin, and I've got this project that I've been working on for many years, but I don't know exactly what direction to move it in. Let's start with a question about molecular hydrogen. Molecular hydrogen is basically two hydrogen atoms that are connected by some kind of chemical bond, and the chemical bond is such that it's not really that stable. If you put a lot of molecular hydrogen together in one place, it has a tendency, if it catches a spark or something like that, and I guess there's a lot of oxygen around to use as fuel. Anyway, it will explode. But what if there is no oxygen around and you just have this molecular hydrogen floating around in space? Can you detect it? And the reason I'm asking this question is not really particularly because I'm interested in chemistry or anything, but it's because of this thing that cosmologists call dark matter. Now, dark matter has a couple of interesting features. We know dark matter is there because of the way spiral galaxies spin, compared to the way, say, solar systems spin. Basically, there's this distribution of velocities. This planet is going to spin around a star faster than this planet, and this planet goes slower than, say, this planet. But in a galaxy, we end up having a situation where this part is spinning a little bit too fast. In order for it to spin that fast, as fast as it does, we have to account for it by the idea that there is matter in here that we cannot see. Now, the current thinking in cosmology is that there's two types of matter, baryonic and nonbaryonic, and the difference between them is that baryonic matter is made of neutrons and protons, while nonbaryonic matter is made of other stuff. And another feature is, with baryonic matter, we can see it, and with nonbaryonic matter, we can't see it. Now, the examples that they frequently use when describing these things is monatomic hydrogen. And all of the hydrogen in our galaxy, all of the hydrogen in our universe, has been mapped by the observation of the 21 centimeter wavelength line of hydrogen gas. And this is an amazing resource because that 21 centimeter line is basically not blocked by anything. It can go anywhere in the universe, so we can see all the way across the universe with this 21 centimeter line. We can tell exactly how fast the monatomic hydrogen is moving, because all we have to do is check the Doppler shift on the 21 centimeter line from that gas. But here's my issue, is that only detects monatomic hydrogen. Molecular hydrogen does not produce that particular frequency of light, because what it is it's when an electron spontaneously changes its orientation. When you got a paired electron, one of them changing its orientation just causes the other one to change, and the energy is immediately absorbed. So here's my conjecture. It's that the dark matter that they're looking for is actually just molecular hydrogen, because we have no means of detecting molecular hydrogen. Not if it's completely by itself. If it's not around oxygen, it's pretty stable. It's going to just stay there until something bothers it. What sorts of things would that molecular hydrogen give you? You would get fuel for the appearance of second-generation stars. You'd get fuel for the periodic Type 1 supernova explosions. I think you'd have some explanation for some of these strange structures. If you imagine the region inside this shell being almost a vacuum, and then a couple of jets coming out from some kind of hypernova or supernova explosion, or coming out and resulting in a spinning of the galaxy. would basically give those jets an invisible substance that they could run into and result in some of these formations that would start spinning in then. So my conjecture, don't misunderstand it, I'm not saying that there are pockets of H2 in certain locations. I'm saying that the entire universe consists of a more or less homogeneous distribution of hydrogen gas. It's everywhere in the universe. The only places where it's empty are these black areas inside, real near the galaxies. So basically, solar wind and supernova explosions has pushed the gas out away from that region. So, like in this picture, the black areas are actually full of a uniform distribution of hydrogen gas, while the regions inside the galaxies are pretty much overall the same density as out here, except this stuff has clumped together and caught on fire. So you may be wondering, how would that H2 have formed? And to answer that question, I kind of need to know what pressures and temperatures conditions can H2 form. Basically, we have a hydrogen atom and another hydrogen atom, and we knock them together, and if they will either stick together or bounce off of each other. It's probably a very simple chemical question. I don't know how to ask the question exactly. I can say at standard temperature and pressure, hydrogen is a colorless, odorless, tasteless, non-toxic,